Okay guys, right, we're moving on. So the next type of sequence, so we've done linear sequences where you add on the same number every time. We've done quadratic sequences where the second difference is a constant. Now I'm just going to talk quickly about exponential sequences. Now you just have to know about them, you don't have to be able to get Tn or any of that. So all you need to know about exponential sequences, you multiply by a constant each time. So 2 goes to 4, goes to 8, goes to 16, goes to 24. You're multiplying by 2 every time. Another example would be 3, 9, 27, 81, 243, etc. It would be multiplying by 3 every time. So exponent, so the word comes from exponential sequence. Exponent is another word for power. So something like 2 to the power of x. So that's 2 to the power of 1, multiplied by 2. Multiply 2 to the power of 3, 2 to the power of 4, 2 to the power of, oh god, that's wrong, 2 to the power of 5, etc. Okay, right, so you're just multiplying. So all you need to know about an exponential sequence is you're multiplying by a constant every time, and they get very big very fast. So look, we're only on term number 5, we're on 32. Term number 6 would be 64, so they've got really big really fast. Okay, that's all you need to know about exponential sequences. Right, okay, now we're going to graph all these sequences. So we have 3 types of sequences. We have a linear sequence where you add on a constant every time. We have a quadratic sequence where the second difference is a constant, and we have an exponential sequence, right, where you're multiplying by a number every time. Okay, so the first one, so to graph a sequence, guys, we put the term number. So you graph the term number versus the term. So the term number goes on the x-axis and the actual term goes on the y-axis. And we see an example now in a sec. Okay, so a linear sequence, right? So a linear sequence, the clue's in the name of it. When we graph a linear sequence, we get a line, right? So linear means line. So when we graph linear sequences, we get a line. For example, so here's a linear sequence. 1 goes to 4, I'm adding on 3, I'm adding on 3, I'm adding on 3, etc. So this is term number 1. This is term number 2. This is term number 3. And this is term number 4. So term number 1 is 1. Term number 2 is 4. Term number 3 is 7. Term number 4 is 10. So you get your graph. Okay. And you graph the term number. So on the x-axis we have the term number. And then on the y-axis we have the actual term. So term number 1 is 1. So term number 1 is 1. Term number 2 is 4. Term number 3 is 7. And term number 4 is 10. Okay, so you get your ruler then and you draw. This is a linear sequence, so we're expecting to get a line, and that's what we get. Okay, so there's my linear sequence. So the term number goes on the x-axis, the actual term goes on the y-axis. Okay, so that's a linear sequence. When we do this, we'll get a straight line. Okay, so I'm moving on now to, and for your notes, just pause the video and write it down. I know I'm flying, but you pause the video and take time to write it down. Quadratic sequence. Right, remember, we've done quadratic graphs. When we did functions, we did quadratic graphs. Okay, a quadratic has a squared term in it. So when we did quadratic graphs, we had an x squared term in it. This one has an n squared term in it. Okay, so a quadratic graph will have a shape. It's either going to be a smiley face or a sad face. Okay, so for example, if we look at this one, this is a quadratic sequence. You add 1, add 2, add 3, add 4. And then if you look at the second difference, right, it'll be 1, 1, 1, 1. Okay, right, so this is a quadratic sequence. So this is term number 1, term number 1, term number 2, term number 3, term number 4, term number 5. Okay, so then to graph that, okay, again, right, you put the term number is on the x-axis. So term number 1 is 3. Term number 2 is 4. Term number 3 is 6. Term number 4 is 9. Term number 5 is 13, and it continues on like that. So look, now, didn't I just say that quadratic graphs will give you a happy face or a sad face? This isn't a happy face or a sad face, but it actually is half a happy face, so it is actually the right shape. Okay, it's just, we've just drawn half of it. So if, you know, you can't have term numbers that are less than 0, but if we were to finish that graph, it would be a smiley face. So it is an actual smiley face, even though it didn't turn out, it's only half a smiley face because you only drew half it. Okay, so that's your quadratic graphs. So they'll end up looking like half a sad face or half a happy face. Okay, right, the last one then is an exponential graph. Remember, exponential graphs, you're multiplying by a number every time. So this one is number 2, multiplying by 2, multiplying by 2, multiplying by 2. And remember, these get really big really fast, okay? So this is term number 1, this is term number 2, term number 3, term number 4. Okay? So term number 1 is 2. Term number 2 is 4, term number 3 is 8, term number 4 is 16. Okay, so we're curving up really big, really fast. Now, that might look like half a happy face, but it's actually not. If you were to continue that, it would go like that, okay? But don't worry about that, okay? So all you need to know is about an exponential graph is you're multiplying by a constant and it gets really big, really fast. Okay, so homework, girls, for the next day, I'm going to ask you to do page 434. These ones are a little bit easier now than the last ones, okay? I hope you'll find them easier. To 435 and just do 1 to 4. So page 434 to 435 and do 1 to 4. Okay, right, thank you.